See it there. Okay. So this is Unit 1, Assignment number 3 notes. This is Period 7, Clovis High School, August 30th, 2022. We are going to be going over these notes right here, which look like that. So we're going to talk about probability. We're going to talk about a strategy called fraction busters. And then we're going to talk about the different ways to classify triangles. Okay, so probability first and foremost. Very basic understanding of probability. Go ahead and draw yourself a number line. This number line represents the smallest answer a probability answer could possibly be, all the way to the largest answer a probability answer could possibly be. The smallest answer a probability answer could be is 0, and the biggest answer can be 1. You could never say the probability of this happening is equal to 2. The biggest answer probability could be is 1. The smallest it could be is 0. And then it could be any answer between 0 and 1. For instance, what's halfway between 0 and 1? I feel like I gave you the answer. Half. You guys said 0.5. Oh, did I tell you that I want you guys to write your answer as fractions for probability? Did I say that yet? Yeah, I did. I just said it. I want you to write your answer as fractions for probability. Ask me why. That is a great question. Thank you for asking me why. Here is the reason why. Because the definition of probability, it has to do with what's the definition of probability. Okay? And the definition is this. Probability is equal to the fraction. The denominator is the total number of possible outcomes. And the numerator is the number of positive outcomes. And we're going to talk about in a second, what does it mean for something to be a positive outcome? Essentially, it means it's what you want to happen. Okay, so here's an example. Here's a very basic example of a probability question. Let's say I have one of these things right here. I'm going to do my best to draw it. Let's say you have a dice or a die. Okay, so that's a die. And I'm going to roll it. And I ask you, what is the probability I'm going to roll a 5? Okay? Remember, when you write probability as an answer, write it as a fraction. And the reason why you write it as a fraction is because of the definition. So the bottom part of the fraction, known as the denominator, is the total number of possible outcomes. So when I roll a die, how many sides does it have? 6. So does that mean there's 6 possible outcomes? Yep. So it's going to be 6. Is going to be your denominator. Now, the numerator is the number of positive outcomes. In this case, what's considered a positive outcome? Rolling a 5. How many 5s are there? 1. So your probability of rolling a 5 is 1 out of 6. Okay? There's a very basic probability, but that's what I mean by total outcomes and positive outcomes. Okay? All right, let's jump back to the number line. If I told you the probability of me shaving my head tonight is 0, what am I telling you? Right, it's not going to happen. I'm not going to shave my head. I don't know. I'm old. If I shave my head, it might not grow back. You know? So, 0 means not going to happen. Period. Exclamation. End of story. Not going to happen. If I told you that tonight, the probability of me dyeing my beard purple is 1, what am I telling you? It doesn't mean I'm probably going to do it, or does it mean it's going to happen? It's going to happen. The probability of 1 means it, whatever it is, will happen. Okay? So whenever probability is 0, it means no chance, no way, no whatever, not going to happen. If probability is 1, it means count on it. It's going to happen. All right? I'm not dyeing my beard purple, though. I think that would look pretty awesome. My goal actually is to gain about 75 pounds between now and like December. And then I dress up as Santa, and I'll make a killing at the mall. You know? Just like take pictures with kids, and I'll make a killing. All right? Okay. So there's probability, you guys. Everybody understand the general concept of probability? Okay, let's review. Probability, you always write the answer as a fraction. You guys are awesome. What's the smallest probability could ever be? 0. What's the biggest probability could ever be? 1. You guys are amazing. Let's move on to probably the part of the notes that you're going to like the least. It's going to deal with fractions. Okay? Don't be scared, though. I'm going to show you a way that you could solve an equation that has fractions by eliminating the fractions. Okay? So here's the equation right here. We're going to solve this. 1/5 x plus 3 is equal to 1/4. Okay? We're going to solve for x in this problem. There are fractions involved. As a matter of fact, if I said, how many fractions are there in this problem, what would you guys say? 2. If I said, how many whole numbers are in this problem, you would say, 1. So how many total parts are there to this problem? 3. You guys following that? There are 3 total parts to this problem. Put parentheses around each part. So put parentheses around the 1/5 x part. Put parentheses around the 3 part. Put parentheses around the 1/4 part. This is a concept. I'm teaching you guys a concept called fraction busters. Fraction busters is pretty cool. I just realized I highlighted yellow on a yellow piece of paper. Let me change that. There we go, fraction busters, okay? Fraction busters are pretty cool because what we're going to do is we're going to do a process and we're going to rewrite the equation without fractions. And then we're going to solve it without fractions, okay? Now, let's look at the fractions. I have a 5 in the denominator. I have a 4 in the denominator. What is the lowest common denominator between 5 and 4? 20. Please write that number outside each one of the parentheses. So fraction busters, first step, put parentheses around each individual part of the equation. Second step, outside each one of the parentheses, write whatever the common denominator is. Now we're going to multiply the number outside the parentheses with the number inside the parentheses. The 20 with the 1. That's 20. I leave the 5 as 5. I leave the x as x. So notice, when I multiplied the 20 with the 1/5 x part, I only multiplied the 20 with the 1. Okay, now I'm going to jump over to the second part, the 3. 20 times 3 is 60. So the second part turns into 60. Then I'm going to jump over to the third part of the equation, the part on the right side of the equal sign. I'm going to multiply the 20 with which number only? The 1, so it becomes 20 over 4. Yes. Oh, yeah. If you want to, you can put a 1 under the 60, but don't. You don't need to, okay? Now, do I still have fractions? Yep. But watch this. I'm now going to divide. Excuse me. Let's go to the first part. What's 20 divided by 5? 4. So this first part turns into 4x plus 60 equals, what does that last part turn into? 5, because 20 divided by 4 is 5. Okay? Look what I just did. Through the miracle of math, it's really not a miracle. I just multiplied really by the common denominator. The equation in gray, believe it or not, has the exact same answer as the equation in black. Okay? I'll say that again, because some students are all, no way, Mr. Trutna, that's impossible. It's possible. The equation in gray has the exact same answer as the equation in black. Do you guys believe me? Yeah. Okay. Let's solve the equation in gray. It's a heck of a lot easier than the equation in black. We're going to subtract 60 from both sides. We have no fractions. 4x is equal to negative 55. Then I'm going to divide negative 55 by 4. And x is going to be equal to negative 13.75. There we go. Okay, so there's an example of if you have to solve an equation with fractions in it, you could work yourself through these steps to rewrite the equation like the one in gray so there are no fractions. Then you solve. Okay, now a couple of questions. Will you always multiply by 20? No. What do you always multiply with? By whatever the common denominator is of the fractions involved in the problem. Okay? Last thing, triangles, types of triangles. There are 6 types of triangles. Okay? Last week I told you 3. There's equilateral triangles. So there's an equilateral triangle. There's an isosceles triangle. And there's a scalene triangle. I introduced you to these 3 triangles last week, if you had never heard of them before. Okay? So underneath each one, let's draw a triangle. I'm going to make all the triangles look the same, more or less, because this will solidify if you guys know what makes each triangle, like what's special about them. Okay, so let's go to the equilateral triangle. What makes a triangle equilateral? All the sides are the same, so let's put the appropriate marks that would indicate all the sides are the same. Okay? How about isosceles triangle? What makes a triangle an isosceles triangle? Two of the sides are the same, but the third side is different. So one way you can do that is like that. This would indicate that those two sides that have those double tick marks on them are the same, but that third side, which has no marks on it, is different. Okay, and how about scalene? What makes a triangle scalene? They're all different, and one way you could do that is put different markings on all three sides to indicate that they're all different than one another. Okay, so equilateral, isosceles, scalene, if you notice, these are classified by the sides. All right? But here's the catch. Triangles just don't have sides. What else do they have? They have angles. So there is ways to classify or get classified by the angles. So not only can you classify triangles by their sides, you could also classify them by what their angles look like. And I'm willing to bet most of you know the different types of triangles that are classified based on what their angles are. What are they? Yep, there's a right triangle, there's an acute triangle, and there's an obtuse triangle. Okay, so we have a right triangle, acute triangle, and obtuse triangle. All right, let's draw a picture of each one. What makes a right triangle a right triangle? Has what? A 90-degree angle in it, as indicated by this little box thingy. Okay. Can a right triangle have two right angles in it? Is that possible? What do you guys think? No, it's impossible. So what's the most right angles a triangle can have in it? Just one. Okay, like that. Is there such a thing as a left angle? No. All right. Okay, how about an acute angle? What makes an angle an acute angle? Right. All the angles are less than 90. All right, so let's draw an example of it. So as long as all three of the angles are less than 90 degrees, as indicated there with 50, 70, and 60 degrees, that's an acute triangle. Okay, so, and I'll just write it here. All three angles are less than 90 degrees. Than 90 degrees. Okay, it has to be all three, by the way, for it to be acute. So this is a silly question, but I still have to ask it because the president told me that I have to ask this. Can a triangle be a right triangle and an acute triangle at the same time? No, it's impossible. Right triangle has 90 degrees. Acute, all the angles are less than 90. Okay, think about this one. Can a triangle be an acute triangle and an equilateral triangle at the same time? Sure it can. Like if you look at this equilateral triangle right here, do all three of the angles look like they're less than 90 degrees? Yeah. How about isosceles? Can a triangle be isosceles and acute at the same time? Yeah. Can a triangle be isosceles and right at the same time?
Oh, I like it.
What do you guys think? Can it? Yeah, it can. You could have a right triangle where two of the sides are equal, but the third side is different. Okay, let's jump to the last one. How about an obtuse triangle? Okay, okay, I heard bigger than 90 degrees. How many of the angles are bigger than 90? Just one. Okay? So typically an obtuse triangle looks something like this, where one of the three angles is definitely bigger than 90. And I'll mark it as 120. Doesn't have to be 120. But guess what type of angles the other two angles are going to be? Acute. So it's going to have one obtuse and two acute angles. Okay, so an obtuse triangle has one obtuse angle two acute angles. All right?